Hello and welcome. Here we are, another day. Another question. Let me just check that the audio is working. Yeah, I took a break for a little bit, for a few hours. And basically exactly what I said would happen is pretty much what happened. Deep breath. Kind of got bored and was like, I don't know what to do. I guess I'll just go do more problems. Yeah, I'm in a weird spot right now where kind of a weird spot in my life right now where I sort of have time to spend, sort of. Um, and yeah, but there's like other things I'd prefer to do. Jeez, what's going on? Other things I would prefer to do, but at the moment I cannot really do those things. It's kind of hard to explain, but basically life is kind of complicated. But anyway, yeah, so I didn't really know what to do with myself, so I was like, all right, I'll just do more problems, just keep going. Got thousands of questions to go. They keep adding more too. It's like kind of annoying. I get through a bunch of questions, and the next week they add like a whole bunch more, and I'm like, I'm actually, I'm past 1,000 on Medium, so I'm getting, I've now solved more than like over 500 of the mediums, and there's only less than 1,000 of the mediums left. All right. Anyway, so let's just keep going. I should be able to solve these kind of quick. See how many I can do in like the next 3 hours or so. See how well I can do here. You are given the root of a binary tree with n nodes, where each node is uniquely assigned a value from 1 to n. You are also given a sequence of n values voyage, which is the desired preorder traversal of the binary tree. Any node in the binary tree can be quote-unquote flipped by swapping its left and right subtrees. For example, flipping node 1 will have the following effect. So 2 and 3, you can flip them here. Flip the smallest number of nodes so that the preorder traversal of the tree matches voyage. Return a list of the values of all flipped nodes. You may return the answer in any order. If it is impossible to flip the nodes in the tree to make the preorder traversal match voyage, return the list -1. Return a list of the values of all flipped nodes. You may return the answer in any order. If it is impossible to flip the nodes in the tree to make the preorder traversal match voyage, return the list -1. So that's a little confusing. I don't know exactly what. Preorder is there's a left subtree and a right subtree. And are they unique? Oh, they are unique. Okay. The preorder traversal, the first node you see is the root, and the next node should be the left subtree, first node of the left subtree, if it exists. And then after you've processed the left subtree, then there should be the right subtree following that. So they give an example, 1, 2, voyage is 2, 1. So you gotta flip, it's impossible to flip the nodes. Yeah, okay. So yeah, you gotta put 2 up here somehow, but there's a 1 there, so you return -1. Then here you've got 1, 2, 3 and 1, 3, 2. So now what is the, okay, well, they don't really explain it, but we have the what do you call that? We have the root node of the tree, and so we have a tree structure. I want to say we don't have an array, so it gets a little confusing. But basically, 1, 3, 2 means you should have a 1 at the root, which we do. Then the 3 and the 2, you could say, okay, I'm expecting a 3 here, and on the left side I have a 2, and the right side I have a 3. I could flip those two. And by flipping those two, that you actually apply it to root 1, to node 1. And so you add that to your return vector, is that you had modified, you've swapped these two nodes, which is equivalent to, which is defined as flipping the parent node. When you have this 2 on the left side, 3 on the right side, and you've swapped the two, What's tricky about this is the voyage. Now it's pre-order. You should go to the left again, and you might have to. So I guess what I'm saying is tricky about it is I think you'd want to do this recursively. One of the problems you could possibly run into here maybe would be, what if you have the tree? You're trying to match the voyage with the tree, so it's actually shouldn't be that hard. It shouldn't be that hard, because if you don't have another value in the like if the other subtree is empty, for example, you don't have duplicates either. Yeah, basically one of these two child nodes must be the one of these two child nodes must be the value that you're looking for. If it's not, then you return a -1. That's pretty much what it comes down to. Yeah, it's interesting. Trying to think how to do this recursively. Well, I'll think about it a little bit more, but so 1, 1, 2 or 3, you have 2, you don't have to flip, and then you see, again, recurse back, you get 3. You can also modify the tree too. There's no reason we can't do that. Trying to think. I think I just want to return an index at the end of my recursive subroutine. And the index is going to give me I could have multiple return values. So I could have just a Boolean that gets set as well. There's a few things I could do. Okay. All right, I'm gonna try something like this. I have some ideas. So this is going to return an integer, which is the index into. There's a few things here. There are a few things. I don't think I need this index actually. Do I need this? I think I do need this. Yeah, we'll just call root. It's fine. All right, recurse on root with index 0. Recurse as the function to call. And then it's also going to have result. Return result, something like this. And the idea is going to be if not root, I think you just return -1. This should be like a, basically you shouldn't check or not root. Pretty much this shouldn't happen. And it's going to be root val is not equal to voyage index. That should be equal. And then we're going to say index is could just return here. So we don't once we've processed the last element of the voyage, we're done. Okay, what's going to happen is we'll say ix1 or a new ix1, a new ix2, something like this. I'll explain in a minute what's going to happen. This is going to be root left and root right. And this is going to be index +1, I think, and this new index 1 + 1, something along these lines. I don't think I actually need the second index at all. So it'll just be new index. There's a few things I didn't explain. So we're going to say const int next val is going to be voyage of index +1. And I'm going to say if there's a left child and a right child. Left exists. So if the left side exists, so if root left and root left val equals next val, then we're in good shape. Basically no op. If root right and root right val is equal to next val, then we swap. Okay. That's the key. And so left check is going to be this one. Oops. Right check is going to be the other one. So if it's the right check, that means it's going to be swapped. If it's neither, if not right left check and not right check, so neither of these work, right? You got to set check equal to false and return -1. All right, something like this. And what you return, by the way, is going to be, oh, this is going to be, yeah, new index 1, new index 2, return new index 2, something like this. So this is a little confusing. I didn't really explain it. I didn't really explain it. I didn't really go through all of it either. So there's a left check and a right check. If I have to swap, then the result is going to be this, the root index, or no, voyage of index. Yeah. Okay. Yeah, the parent. And if it's a left check, we don't do anything, right? We just go straight through. If it's a right check, we're going to push into the voyage and swap. And if there's neither left check nor right check, that means we couldn't find the value. That means we have to return -1 and set our check here to false. Here what we would do is check equal to true, excuse me. Yeah. The new index is going to be, so we recurse with index +1. If we found something, now we have the value on the left side. Let's say we get some index into voyage at the end of that. We call the next iteration with that new index +1. That new index is going to be the last index that was processed. So after processing the subtree, this will be the. So I think it's actually supposed to be +1, which is confusing. I'm not sure about that. Now I'm thinking about it. Because here, so we got the value at the index, and we checked it, and now we want to get the next value. And we know our preorder that it'll line up in that case. We then look for what we ended up with here. So I guess my question is, what the input is something I'm going to process that input, that value. What this should return is actually something that was the last index that was processed. So the input is going to be the index that hasn't been processed yet, right? And when I call these routines, this is going to process this next index. And what it's going to return is the last index that was processed. And so then I get a +1 on that. And then I return the last index that was processed again. Yeah, it's really confusing, but I think it's how that works. And then finally, this is just a ternary at the end. So check then is true. Then we're going to return -1. Otherwise, return the result. Something along these lines, I think, is what we want. What I want. And I could try some different. Excuse me. I could try some different things, or it's just wrong. Okay. I could try different test cases. So 20 minutes now. Output -1, expected 1. Okay. What happened? What? Yeah. Why? Huh. How are we doing here? So we start at 1, then we go to 3, and then we just return a -1. Why does that happen? We should swap the 2, and then... Oh. Just... I don't know, I didn't even think about this part. If there's not a left side or a right side, that's a leaf. I don't need to worry about that. When a leaf is finished, basically it's just ix plus 1. I think that's it. It's the last index that was processed. If it matches, then yeah, okay. That's confusing, but yeah. That's confusing. That's really confusing. Yeah, so when the leaf is processed, obviously it already passed this check, so you could just return that index. That's kind of it. Gee, all right. Let's try some other more complicated test cases. I don't know, let's do 4, 5, 6, 7. The voyage is going to be, I don't know, 1, 3, so we swap, and then it's going to go 7, 6. And then, so 1, 3, 7, 6, and say 2, 4, 5. All right, let's go for that. See what that looks like. Okay. All right, let's do a more complicated thing. Let's like remove node 3, put a null in there. Make it look like this. Now we have 1. We don't have a 3 anymore. I think the only thing you could do is have a 2 at that point. Then 4 and 5, it could be 5 and 4. And then 7 and 6, I guess. 7, 6, something like this. Root from 1 to 6 only. Oh, 3, 4, 5, 6. Just decrement by 1. Something like this. Huh. Interesting question. Okay, this might be it. I don't know. Did I do... Let's look at some of the more unusual cases. It could be 1 and 1. Let's make everything 1. See what happens. It's just 1, 1, and 1. All right. I think I'm going to try to submit it. See what I get. I could have it wrong. I could be doing something wrong and not realize it. There's a good chance of that. Ooh, ouch. No. Shoot. 1 null 2 1 2. Oh no. Yeah, I probably should have tested more. It's kind of complicated code, complicated logic here. Output 1 expected empty. Oh no. What? Oh shoot. Oh, I didn't think about that. Ooh. You don't always swap the right side. Yeah, I don't know. I kind of like tried to think about that before. Like it just didn't. I didn't see it. Didn't realize it. Ah, that's so bad. That's so like disappointing. I'm so disappointed. I get very I have a lot of bitterness, and I guess I call it envy. You could say, but I don't know. I get like bitter, and it's a form of envy, I suppose. When I look at other people and it's not explained how it is that they got to where they are, and then like when I struggle, I get really upset because like I'm like, yeah, but then here's this person that's like way ahead of me somehow, and meanwhile I'm struggling and I'm like way behind them and I'm struggling. And it makes me so much more upset. Like if I just didn't even know these people were doing these things, I'd be, I think, happier because I'd be like, all right, well, I'm where I am because of the things that happened, and like, a lot of this stuff I didn't really have. Wasn't a lot I could do. It was just kind of like it's your lot in life. Yeah, it's I don't know. I mean, yeah, I don't know. I shouldn't. It's not really good. It's not really good to compare yourself to other people when, like especially when the playing field is obviously not level. Like obviously, there's something going on here that's not right, not fair. If these people are just like wildly successful, kind of for no apparent reason, and you're just like struggling like an animal, and you can't even come close, and you're just, these sorts of things just make me feel like very I don't know, it bothers me. I don't know, I shouldn't get so upset, and it shouldn't bother me so much, but I have to like contend with that stuff. And it's probably not true that like these people had the exact same situations, circumstances, and opportunities and whatnot that you had. It's like, no, it's not the world that we live in, not at all. It's kind of a fraud. But anyway, let me not get into all that. But yeah, it kind of just makes the when I get something wrong, or when I struggle with something, it makes it sting that much more, knowing that it's like, oh, you're like really behind, extremely far behind. But what can you do? What can you do, right? You kind of only have one choice, and that's to just keep going forward. But anyway, so I don't know what happened here, how I missed this, because I did think about this. I was like, I know with pre-order stuff, there's this weird thing that goes on where the left and the right can be like basically squished together, which is kind of what happened here, right? If you look at the test case, the pre-order is still 1 2, and you actually don't need to modify anything because it'll just skip the left side altogether. I don't know. I guess I just didn't think it all the way through. Maybe. I did briefly ponder it though, because I was like, I know there's something weird that goes on with that with pre-order traversals. I probably should have just walked through it. That like, what happens if I'm missing the left subtree? And I should have just tried some left subtree test cases. Actually, that would have been fun. Like if I just tried this one, the left subtree was missing. What that would look like. I should have just tried it. One subtree missing, the other subtree missing. What happens if there's a problem or not? Yeah. So what I coded is not correct in this case. What should happen is if the left check fails, right? It's actually a little more complicated than that. So if it's not a left check, if it's if the root left doesn't exist, right? But the right check works, then you do this. So I would say if root left exists, If the root left doesn't exist, then you don't have to do anything there. And the index you're going to get where the root left doesn't exist is, I think if not root, just return the same index again. It's probably fine. Yeah, so if the left doesn't exist at all, that subtree, then just return ix plus 1. I think you'd return ix minus 1. Is probably the correct thing to do. Let's try it, if that works. Should maybe make it try a little, yeah, okay. Let me try a little more sophisticated example of the same thing. So now we can do 3, 4, 5, 6. Let's do, this is null. 3, 4, 5. And this is just 1, 2, 3, 5, 4. Right, a little more complicated. All right, I'm gonna try it again. I probably should try more test cases, but I'm gonna go with this just to see what happens. I probably should have thought about it a little more. Oh, I got it, okay. Yeah, that's a good question. That's kind of a tricky one. Got it wrong. Got it wrong, man. Sucks. It's kind of hard to go through all the logic there. I mean, look at how many if statements I have here. A lot of elements to this. 1 if statement, 2 if statement, 3 if statements, 4, 5. I think this needs to be, I think you could just AND this, no? Right? Because you don't, yeah, the other cases you do the same nothing. Yeah, it's like logically quite a lot going on here. There's quite a few things happening. It's kind of involved. Maybe not the best solution. Really had to think this one through. Let me try submitting. I'll submit it like 5 times and we'll go to the next question. That was like half an hour. Okay, not great, but not terrible. Not great, not terrible, but not good how long it took. And also it's pretty like slow runtime. 2, 3, 4. I don't know if I could really improve that runtime very much. I'll go for like 7 submissions. Oh, there we go. Got it. Hey, 100%. Hail victory. Hail victory. So yeah, I should also open this again. Let's do it. 1, 2, 3, 1, 1, 2, 3, 4, 5. We'll go to 7. Alrighty. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. One more. That'll be that. Yeah, it's almost like doesn't matter how many problems I solve, I'll always like struggle with something here. There'll always be the opportunity for me to make a mistake. Dang. K closest points to origin. All right. Oh no. Let me not open it yet. I opened it too soon. Okay. What I should do now, I'm going to do now is I'm going to stop the stream here. Stop the stream here, and then restart it with a different title. Okay. So yeah, thanks for watching. If you like the stream, don't forget to